Okay, okay, welcome back to our data science and data analytics course. I hope all of you have, those who have appeared end semester exam, have done very well. And thing is that we have very less time to complete our syllabus. So I think within 15 days we will have to wind up the syllabus uh, because it's instruction from NPIU to complete it before 30th of September. Already I have sent you some link regarding when the three external have given their consent to give their presentation, give their time for our hands-on session for our data science training program. Okay, so the dates are fixed, but time I will mention it later. Okay, so for today's class, already I have discussed a little bit since our last class. We are discussing about probability, and we have discussed about conditional probability, independence and dependence. Okay, all these things have been completed. For the timing, we have to the remaining part of the syllabus are that is probability density function, probability distributions. Okay, Bayes theorem, and that is the part of statistics. Then the remaining are our hypothesis testing. Okay, after that the next module covers about machine learning, different concept of machine learning programs. Okay, so I will do some hands-on on that particular module. Over here also we can do it some hands-on on this mathematical foundation. But thing is that due to insufficient time, I have not come with the programs. Maybe time will permit, I will teach you later. Uh, okay. So today this interface has been changed. Let me see where are the links where I can share the whole screen with you. Okay. Okay. So already I have sent two PDF files. That is one copy of my notebook. You should download it, and we'll uh, discuss the topics from there. Okay. And this one. Okay. So the syllabus covers about random variables. Let me say you the topics. Okay. So the remaining parts are like conditional probability based theorem, random variables. So today I have planned to discuss about random variables and continuous distribution. Before continuous distribution, we have to discuss about discrete probability distribution. Then we can discuss the continuous. Then it will be easy to understand what is continuous distribution. Okay, and most of the application of continuous distribution is in the data science. It's mostly related to how to deal with samples. Means because we are not dealing with directly population, because population is the large amount of data. Okay, so we are concerned about samples. So in that field we have to means do some experiment using this continuous data. Okay, then next topic is normal distribution. So normal distribution is part of continuous distribution. So before continues, we have to discuss this discrete probability distribution. So today this the topic of discussion is random variable and discrete probability distribution. Okay, just see what is random variable. So random variable is just see the definition that I mentioned over here. That a variable whose value is determined by a random experiment. When means you have a experiment, you can take in mathematically as a function f of x, okay, which will give some output based upon some input x, okay. So y is equal to f of x, that is some based upon some input, some output is you are getting, okay. So here in the case of probability distribution, random variable may be what may be the outcome when you are touching coins, okay. Two coins you are touching simultaneously, then what may be the outcome? That may be the means that outcome is part of the variable, okay. So variable is denoted by capital X, okay, and small x is means this is just see here somewhere we have discussed written this capital X, okay, and this when we are tossing the coin we are getting some value, so that is the value when we are getting this outcome, okay. Just see uh, discrete probability distribution, the table or formula that list just wait. Okay. So discrete probability distribution means you will be getting it slowly, because with the examples it will be easy to understand. Before that, just let me read these definitions. Tabular formula that lists the probabilities for each outcome of the random variable x. Okay. This is the definition of discrete probability distribution. For example, let's take three coins at same time, okay, and what may be the outcome? The outcome may be the outcome may be head, and three times all the three coins will flip, and the output will be all three will show head, and maybe this is the combination, okay. So two heads and one tail, and first one is head, then middle one is tail, like this, like in binary format you can means, represent it like head tail, okay. So if the purpose is that let random variable x be number of head, okay. So random variable we have to count how many number of head are there in the outcome. So here there are three heads, there are two heads in the second experiment. These are the number of experiments. So in one experiment, three coins are flipped simultaneously. Okay, it is tossed simultaneously. So this is one experiment. Okay, and the second one is another experiment. Just wait, I am just searching for the marker. Okay, you see three heads in the first experiment, in the second experiment two heads, so that's why the outcome we are considering like this, okay. So in discrete probability distributions, what are the possibilities? The possibilities are two times head, three times head, one time head, and zero. Other than that, there is no other means values we are getting. We are getting either 0, 1, 2, or 3. So these are the possible outcomes. Okay, 1, 2, 3. So the discrete probability we are representing in terms of this tabular format. So if x is if we are interested to find what is the probability of getting 0 if you are tossing the coin. means, three coins simultaneously. So this is the output. That is the probability is 1 upon 8. So 0 is here. You just count how many times 0 has happened. So this is 1 upon 8 because 8 number of possibilities are there if you will toss the coins. Okay, and that is 1 upon 8. And the probability of 1 is 3 upon 8. Uh, Somebody creating noise. Just mute your mic. Okay. You see, here is uh, the probability of getting two heads simultaneously. Uh, that is 3 upon 8, and this is number of three heads simultaneously, that is 1 upon 8. Okay, just see, that is once you can only get, there is one chance that you can get uh, all these three coins flipping as head. Okay, so that is the total probability of the experiment will be 1, that you know, that maximum probability is 1. Okay, so probability distribution for x, sum of two rolled dice. So this is the probability. Just see, if you want to flip and two dice, sorry, probability distribution for x, sum of two rolled dice. So two dice has been rolled simultaneously. So the possibilities are the like means the sum we are interested in to find what is the sum. Okay. Uh, okay. So sum of two roll dice. Sum of two roll dice means uh, if one will give you one, and the second dice will give 5, so total is 6. Similarly, the maximum value we can get up to 12, because there is a chance that we can get both the dice having the flipped value as 6 and 6. So maximum value, it will not exceed 12. Okay, so now the minimum value is not also because less than 0 there is no chances, because the means number of the values are starting from 1 to 6. So that's why you have counted. These are the possible values that 2 will occur. Means if there is a chance that both the dice will have 1 and 1, so the sum is minimum value is 2. Okay, so the probability is 1 upon 36, because there is a 6 sides are there in a dice. So 6 into 6, 36. Similarly, the number of so the sum is 3. How many possibilities are there? That there are two possibilities are there to find sum. It's a possibility like 1 plus 2 and 2 plus 1. Okay, there is 3, and this is also 3, and so that's why it is 2. Okay, and the value we'll get sum is 4. So the random value 4 we can get. So these are the possible values of the random variable x, capital X. So the possible values are 2, 3, 4, 5, 6, 7 up to 12. So value 4 we can get in rolling two dice. So that is we can get either 2 in both the means dice. uh, this is one possible condition. Another is 3 1 and 1 3. Okay, so that's why 3 upon 36. Similarly, this is 4 upon 36. 5 means 2, 3 3 2, second 3 2, and what else? Just wait. Okay, so likely like that you have to count the possible values. That is total number is 4. 4 upon 36. 5 is you can get either 4 1. Okay, 4 1 or 1 4. Okay, 1 4, and 3 2, 2 3. So total 4 number of values are there. Similarly, the 12 value you can get only once, because there is no other possibilities. That is, you can get either 6 or 6, then only it is counted as 12 value. So the random value 12 you will get 1, so 1 by 36. So these are the probabilities. If you make a summation of all these, then you will get 36 by 36, that is 1. That is maximum probability value of rolling two dice simultaneously. So the question is, what is the probability of getting a sum is 10. So this is exactly the see, this the topic is concerned about discrete probability distribution. Discrete means you when you are flipping the coin or rolling the dice, there is a chance that you will get the values 3, 2, 1, 0, like these values. Okay, so nowhere you are getting 1.5 or 3.22 like that. All these means decimal value chances are not there. Okay, so discrete and continuous. So these probability distributions are of two types, that is discrete and continuous. Discrete means the values are rounded to some integer values like 1, 2, 3, like that, and negative 2, 3. So that one is not possible here, but some other experiments are there where we can if the function, the random function, for generating this random variable. Just hold on. Okay, the random function is actually generating these values. Okay, so these random values it is generating because these values are in discrete in numbers, so that's why it is called discrete probability distributions. In the second experiment, second example, just see, we are every time we are getting an integer value either 2, 3, 4, 12. It is there is no chance that you will get a value 10 to 11 like 10.1, 10.5, 10.6, like that. These values are not possible over here, so that's why these events are called discrete events. And uh, the values we are getting, the random values we are getting, that is discrete values. Okay. Okay, so now just see how to calculate the probability of what is the probability of getting a sum as 10. Okay, so finding means what is the probability you can find over here, that is 3 upon 36. Okay, so maybe the second question is what is the probability of getting less than or equal to 9. So you have to calculate the probability of okay, means this distribution. The whole thing will be called as probability distribution. Okay, and only finding probability of getting 8, only finding probability of getting 10, only finding that is you can count directly. But the second question is what is the probability of getting less than or equal to 9. So you have to sum all these values. Less than equal to means you have to calculate 1 by 36 plus 2 by 36 up to 9 means plus 4 by 36. Okay, up to this much you have to calculate. So that is the solution of the second question. Then what is the probability of getting a sum less than or equal to 9? Okay, so sum is 9, so less than is all these possibilities are there. So we have to calculate the sum of all this, and this will be the solution. So now come to the topic is we have to find the mean and variance of discrete events, and that is the probability distribution mean, how to calculate that. Okay, suppose here is an example. This is the distribution given, and all these events are means discrete in nature. You can get it over here that it is a 0 value, this is a 1 value, this is a 2 value. So the real example is on the next page, where it is from where which type of means application this distribution has been collected. I will discuss it. Just see the mean value of the distribution, like a mean median mode we are getting from simple data or its frequency. So now this is the probability distribution is given, and this is a discrete probability distribution. We have to find the mean. So the formula is, if you remember from 12th mathematics, just here I have put this formula. The expected value of random variable is the theoretical mean of the random variable. So mean means the expected value of random variable all these are all random variables. Okay, is the theoretical mean of the expected value. So we have to calculate the expected value. So that is also called the mean of this discrete probability distribution. Okay, so to calculate the expected value for a discrete random variable x, so this is expected of x equal to summation of all x, that is multiplied x into probability of x. So this is x with the random value x. Okay, the putting some values like 0, 1, 2, 0, 1, 2. Okay, three random values are there of capital X. Okay, and now the probability is also given. So this is the formula. You have to multiply 0 into 0.16, 1 into 0.46 plus 1 into 0.16 plus 2 into 0.36. So that will be considered as the expected value or the mean of the probability distribution. So this formula you have to remember. Maybe short problem will come in the exam. You have to find the mean of the distribution of this discrete probability distribution. Okay, so data sets will be given, this distribution will be given. You have to find the mean. So that mean you have to calculate by multiplying the means random value with its probability of the number of chances that you have to multiply and make a sum. So that will be called as expected value of x or mean, and we are representing in terms of this is Greek letter mean. Okay, and another term is called variance. Okay, so here variance, we'll discuss more on this mean, how in the mean is related to our data set, how it will be helpful for doing experiment. So that will be discussed later, but for the time being you should understand the basic concept of mean, median, mode, and how we are calculating for this probability density functions, probability distributions. Okay, so that thing you just go through and try to solve some problems, then only you will get to know what is its practical application. Okay, uh, just see another means term we have to find the another parameter. So the parameter is called variance. So variance is, the formula is x minus mu whole square equal to this is called variance, or we are calling it sigma square. This the remaining part is not visible. So this is called sigma square. Yes, variance, and we are representing in terms of sigma. So small sigma, this is not capital, small sigma square, and standard deviation is root over of sigma, sigma square, that is only sigma. Okay, so whatever variance you will get, just make a square root of that, you will get standard deviation. This is the fundamental thing we have learned earlier. So we will find the variance of this probability distribution, discrete probability distribution. So that formula is, to find this variance of this distribution, the formula is for all x, this is summation x minus mu. Mu is the mean which you will calculate from here, and make a square and multiply with the probability values each with each x. So this is small x. This is the random x, capital X, and the small x is the part of capital X. So 0, 1, 2, 3, 0, 1, 2. So 0 minus mu is some value we will get. Make a square, multiply with its probability. Then 1 minus its mean value. Make a square and multiply with its probability. Similarly, 2 minus this mean value, make a square and multiply with its probability. Make a means at the end you will get a particular value, and by adding all these values. Okay, so we'll get to understand with the simple example. Okay, so another formula you have to remember that this variance x minus mu square equal to this is expected of x square minus expectation of x whole square. So this formula will be useful for now or as well as in the continuous distribution. Just remember this formula, somewhere it will be useful. So here is a real life example. Suppose 60% of Indian adults approve of the way the prime minister is handling his job, whether he is handling his job in right way or not. So that thing we have to means calculate. means what is the probability that if the probability is better, maybe more than 50%, then it is the will be assumed that the prime minister is doing very good job. Okay, so we have not calculated the taken data from all individual. This is not possible for everyone to collect the data from every Indians. That's why we just taken two possible randomly sample two Indian adults. So let X represent the number that approve. So it can X can take values less than 2 because we have taken okay, randomly sampled two Indian adults. Okay, so then the means out of the two Indian adults, maybe both will say no, he is not in the right way, or one will means raise hand that he will be supporting prime minister, or both will. These are the possibilities. Okay, or both will also agree with the statement. Okay, so these are the possibilities. So it may be none or one or two. It is not more than that. So that's why X can represent the number that approves. Means they will approve. So X can take values less than equal to 2. So it's not exceeding 2, or because we have taken two Indian means sample values with two Indians. Okay, so the probability distribution of X can be, so that is the data taken from previous example, this one. So this is the value, the probability distribution is taken, is given over here. So for small value X, okay, small x, this is 0 taken. Okay, so this is the random value 0 1 2. So the probabilities are given. So find the mean and variance and standard deviation. Okay, so to find with this data, and this is the example where it is applied, and with this distribution we have to find what is the mean. So it is 0 into 0.16 plus 1 into, as I told you, this is the formula, x into probability of x. So the probability of x is given, also the random values x is given. Okay, so 1 into 0.48 plus 2 into 0.36, so total is 1.2. So this is exactly the mean. Okay, so this 1.2 is the mean value or expected value of the random value x. Okay, so now the expectation of x is 1.2. Okay, now just see, we have to calculate this expectation of x square to find its variance, that is this one. Already I have shown you this formula. If expected value of x square, we have to compare that one. Okay, so expected value of x square is equal to sum of all x square into px. That means whatever the value of x is, that we have to multiply twice. So that is the power of x square. So 0 square plus 0 square, this one 0 square plus into 0.16, 1 square into 0.48, 2 square into 0.36. So that thing is taken considered over here. The total value is 1.92. Okay, so now just see, you just apply that formula, x minus mu square, x minus mu whole square equal to variance formula is for all x, x minus mu square probability of x. uh, that is, you have to subtract 0 minus mean. The variance formula is this one. Okay, so mean, this mu is the mean we have calculated just now some time before over here. This one is the mu. Okay, and now you have to use this mean mu value to calculate the variance. So x minus mu square, x is 0 and 1 and 2. So from every x you have to subtract the mean value 1.2, 1.2, 1.2, and make a square and multiply with its probability value. So we are getting, at the end we are getting 0.48. So that 0.48 is the variance. So sigma square is 0.48, and this is called the variance. And standard deviation sigma equal to root over of 0.48. Okay, now just see, as I shown you the formula earlier, that I have mentioned it as equation 1. Equation 1. So just see, according to the equation 1, if you will apply the formula, this is now we calculated this x minus mu square equal to 0.48 from here we have calculated. Now just see, this expected value of x square we calculated just some time before over here, by multiplying the x two times, power of x we have calculated and multiplied with its probability. At the end we are getting expected value of x square, and just put that value. That value is 1.92, and this is the mean value we calculated sometime before over here, mean value, and subtract it, you will get again 0.48. So this formula is, means with this example we are also proving that the left side is equal to RHS, LHS equal to RHS. That means this one is also equal to this one. The formula is proved over here with this simple example. Okay, now come to, okay. Okay, just see random variables. What are random variables? It is another definition. It is nothing but a variable that stores some values so that we can use that predictable values. So random variable we are representing in terms of capital X. Sometime before I mentioned X, capital X, and it can use some that random variable can store some values. That some values is like this 2, 3, 4, this 0, 1, 2, 3, 0, 1, 2. So these are some values that can be stored in this random variable, so that we can use that predictable values. Okay, so there are different types of random variables. So one is called numerical random variable, another is called categorical random variable. So again, numerical random variable can be, it can be discrete or it can be continuous. So the discrete is example of discrete random variable is number of people that may be countable in terms of integer format. So that is example. Okay, so continuous variable example is height of a person, so that the height cannot be means only integer, it can be more than that, that is floating point values, it can be also accepted. Okay, so that's why continuous values, when we will plot the continuous values in terms of histogram, the plot will be little bit smoother than these discrete variables. Okay, so this discrete random variables. Okay, so we'll see that example sometime after. One more type is over here, the rate of interest ROI. In the data set, we'll dealing with data set after some in the next module when we'll do some experiment using machine learning. Okay, so the data sets will have some number of dimension, and each dimension will have some values. So each values will be considered as random values. Okay, so these random values will be collected maybe from original source, or it can be generated from the machines for doing experiments. Okay, so that will be means here the values are repeated, male, female, all these are called categorical variables, and these are called means continuous variables. Okay, continuous random variables, and these are called discrete random variables, because age can be 23.4, but we are considering whether you are 23 or 24. Somewhere we are not considering 23.1 1 month, and small some 7 days like that. We are not considering like that. We are only mentioning whether you are 23 or you are 24. Based upon that, you are qualified or not qualified for the next round or somewhere. Okay, for selection purpose. So these are the different types of data. Random values you will be getting when you will deal with data sets. Okay, so now come to after the means discrete this example already we discussed. After this discrete probability distribution, now we'll discuss about continuous probability distribution. Okay, just see continuous probability distribution. So just I mentioned you that it is in the format like not like only integer, it may be floating point values 2.3, 2.7. There are number of values present, infinity number of values present between two integer values. These can be considered for continuous. This will be considered as continuous random values. Okay, so continuous random variables can take on an infinity number of possible values corresponding to every value in an interval. So the interval may be 3 to 4 or 0 to infinity. So these are between these 3 and 4 we will get a number of values. Okay. So we cannot model continuous random variables with the same method we used for discrete random variable. I just mentioned you that how to find the mean and variance, standard deviation, all these things. These are the formula we have to multiply with this means its probability and random values are multiplied to find, and at the end we are making a sum to find the mean value. But that is not the case for continuous probability distribution. So there is a little bit change in means concept in the case of continuous probability distribution. So we model a continuous random variable with a curve f of x called a probability density function. So that f of x will be plotted like probability density function. It will be similar to this way. Okay, so means this will be a straight line. Okay, x and y. Okay, and the distribution will look like this, maybe this way, or it may be this way. Okay, or it may be so this will be based upon the function f of x. So we model a continuous random variable with a curve f of x based upon the value of so whether it is, if the f of x is constant. Okay, then you will get a probability density function plotting like this. Okay, now here is one example distribution of height of adult. This is Canadian male example is taken from internet. Just see here the average height of the male person in Canada is 170 centimeter. Here, according to this plot, okay. Uh, means here this is one type of means distribution, probability distribution function, and the density function looks like it is normal, means it is going off again down, but it's not. Here another just example, you just see distribution of time of failure in thousands of hour for a type of light bulbs. Okay, so the light bulbs means failure case is considered, and the distribution is plotted over here, and it is looking like this. It is not like normal. This is called normal probability density function, but here it is not normal. Okay, so f of x represents the height of the curve at point x for continuous random variable probability or area under the curve. So the probability for this one is important. So the probability for continuous random variables, to find the probability, we are interested for finding probability of the different distributions. Just we discussed discrete distribution. Now it is the case for continuous distribution. So how to find this probability? That is the question over here. Okay. So for continuous random variables, probability is calculated by calculating the area under the curve. So area under the curve means this one. So this one is the whole curve. This whole curve starting from here and till here, it is some area it is covering. Okay, so we are considering this as f of x. So we have to use integration technique, calculus technique to find area. Suppose we have to find what is the probability of means this is the number of case. This is 2 and 4. Maybe it is in terms of hour, 2 hour and 4 hours, thousands of hour, 2000 hour or 4000 hour. Okay, after 4000 hour, all the bulbs are means there is a failure case. Okay, that is less than zero. Okay, so now my point is that here uh, to find the probability of a particular value for a continuous value, we have to find the area under the curve. So area under the curve means this area we have to calculate. Means okay. if you want to interested to find the failure case for less than 2000 hour, so then we have to calculate the area of this curve, area under the curve. This curve is there, so under the curve means under this till x-axis what is the area. So based upon that, the calculation, the probability will be calculated. Okay, so now we'll see some small example. Okay, so now just see, if this is not possible to find area of, if you calculate probability of A over here, it is not possible. Like earlier we have seen in the discrete case, we have calculated the probability of getting a 9, sum is 9, that is possible, that is we are getting as 4 by 36. But that thing is not possible over here. Over here, uh, okay. So now if you will say that exactly in 2000 hour, what is the number of failure cases in the case of light bulbs? Okay. So that is exactly zero. Here if you will say probability of x equal to zero, the random variable, when the value, when it is given a is the random value to the it is considered as random value, then the probability is zero. Similarly, if you will say 3.12 random value, the probability is also zero. Okay, so you have to calculate the probability in a range because it is continuous distribution. So you have to calculate the probability of a, between a and b. So that is possible. So that we have to calculate using the integration technique. Okay, so now just see, for any continuous probability distribution f of x greater than 0 for all x, the area under the curve is equal to 1. So the total area of the curve is 1. Always for continuous distribution, just remember that this area under the curve is considered as 1. Okay, so it is not exceeding 1 because the probability, whole probability of this curve is 1. Okay, so that is, if you are interested to find the area under the curve till this one, that is less than value a, so that we have to calculate by integrating from minus infinity to a. Okay, integration from minus infinity to a. Similarly, if you want to find area under the curve, means from greater than b value, suppose this is one, means year, this is another year for the case of this failure case of bulb. Okay, so now you have to calculate the area of this remaining part. Okay, so now this is called normal distribution. Actually, the black one is not in the correct position. That's why I have written it, drawn it once again. So the normal curve looks like it's a normal way. So why it is the name normal, that once I will say later, but I don't remember it right now. Now the thing is that there are a number of common continuous probability distribution that uh, come up frequently in theory and practices. Means every time you will do some experiment, you will come across some normal distributions or continuous normal distribution, means that are common. Okay, so the one of the common continuous probability distribution is called normal distribution. Okay, so there are some many more properties of normal distributions, I will say you later, but for the timing I will say that this one will be called as mean. For normal distribution, the mean, median and mode both will, the three will lie in a single point. For other case, the mean will lie maybe over here, the mean, the, for other case maybe this one. Okay, the mean may lie over here. Okay, but the mode will lie over here. Mode means, as you know, the statistical technique, mode is the maximum frequency of the of a particular event. Okay, so the one which is means occurring most of the time, that is called mode. Okay, mean is the average value of the total experiment. So the mean, median, and mode three will lie in a single line in a middle position, and it will partition the whole distribution into two parts. That means if the total distribution is called, considered as probability equal to probability of this distribution is equal to 1. Okay, and the mean will partition the mean value after calculating the mean. That's why we are discussing about mean and variance. sometime before. So that is much more important for doing experiment, for analyzing whether your experiment is going on in the right way, or it's giving bad performance or good performance. That can be possible only if you use the statistical techniques. Okay, that's why in this course the statistical or techniques are being introduced in this mathematical foundation part. Okay, so that's just you have to go understand the concept